And in this tutorial, we're going to be talking about appending to our doubly linked list. So appending to our doubly linked list just means inserting the node at the end of the list. Now, there are two test cases. One is if the list is empty, and one if the list is not empty. So our first case is when the list is empty. So in order to do that, we need to check to see whether the list is empty. And we could do so by saying if the header is equal to null, that means it's an empty list. Likewise, we could check to see if the size is equal to 0, and that means it's also an empty list. So the first step is to actually create the new node that we want to append to our linked list. And the second step is to have both the header and our tail pointers point to the newly created node. And the reason why header and tail is both pointing to n is because n is the only node within our list. So header is always supposed to point to the first node, and tail is always supposed to point to the last node. But since n is the only node within our list, both header and tail both point to n. And the last step is to increment the size. Alright, so now from here, what I want to do is go on to case 2. What happens when our doubly linked list is not empty? So here, you can see that we have our doubly linked list here, and that it has 3 nodes within it. So the most logical place to start, if I want to add something to the end of the list, is the tail, because tail is always pointing to the last node. Now, where do I want to insert this new node? Well, since tail is pointing to the last node, I have access to this node. So I could say tail arrow next is going to point to the new node. So let's actually create the new node. Now, once we create the new node, we want to insert it where tail arrow next is pointing to, which will make this node point to n. So now we formed a link between these two nodes. But remember, since this is a doubly linked list, n has to point to the previous node. So who has a pointer to the previous node? Tail does. So if I say n arrow prev is going to point to what tail is pointing to. So now that would complete the link. Tail arrow next is pointing to n, and n arrow prev is pointing to tail. But now we need to update what tail is pointing to, because tail is pointing to the previous last node, but n is the current last node. So now we just set tail to point to n. And the last step from here, since we successfully inserted a new node to our list, increment the size. Alright, so now let's actually take a look at how we would write this in code. Alright, so from here you can see we have our append method. It's not going to be returning anything, and we're passing in data. So now let's move on to step 1. We're going to have to create the node that we want to insert at the back of the list. So in order to do that, I'm just going to come down here and say node n is going to be equal to new node, and we're just going to pass in the data. Now from here, let's move on to case 1. Check if the list is empty. Well, in order to check if the list is empty, I could just say if the header is equal to null, then we know the list is empty. We could also say if size is equal to 0, then we know it's also an empty list. So from here, we're just going to say header is going to be pointing to n, and tail is going to be pointing to n. And that's because n is the only node within our list. That means the header that points to the first node is going to point to n, and tail that points to the last node is also going to point to n. So now let's move on to case 2. Check if the list is not empty. So since we did case 1 and checked to see if the list is empty, we could just use an else statement, because if the list is empty, then this code would execute. But since it's not empty, then the else statement would execute. Alright, so the first step is to make what tail is pointing to its next pointer point to n. So I could just say tail arrow next, and that's going to point to n. And remember, tail is pointing to the last node, so we're accessing the next pointer and making it point to n. So now from here, we need n to point to the previous last node, which tail has a pointer to. So now I could say something like this. N arrow prev points to tail. And the last step, since we linked these two nodes together, is to update what tail is pointing to, because tail needs to point to the newly inserted node, because n is now the last node within the list. So now I could just say tail points to n. And the last step, increment the size. All right, so now from here, let's actually test to see if this is working out. So I'm just going to go down to our main method. We're going to change all of these to append. I'm going to save. I'm going to bring up the console, change to my desktop. Let's compile it. And now let's execute it. So you can see we have our list here. We append 1, 2, 3. So we get the output of 1, 2, and 3. That's because it's always adding towards the end of the list. So that pretty much wraps it up for our doubly linked list append method.